let's talk about one of the most incredible devices in your home, the refrigerator. I mean, it's a box that somehow, almost magically, makes things cold. Today, we're going to pull back the curtain and see how a basic principle of chemistry is the secret to keeping your food fresh.
I know. It sounds like a trick question, right? On one hand, you've got this disposable pouch you crack to make it cold. On the other, a big, complex machine that's always running. But believe it or not, the science that makes them both work is exactly the same.
So what is this big secret? Well, it all comes down to two sides of the same chemical coin. Two opposite processes that are the key to controlling temperature itself. All right, here are two key players, exothermic and endothermic. You know those little hand warmer packets you use in the winter? That's a perfect example of an exothermic reaction. It gives off heat, making everything around it warmer. But endothermic, that's where the real magic for us is today. It does the complete opposite. It actually sucks in heat from its surroundings, which makes things feel cold. And that is our secret weapon.
And what's wild is that you don't need a fancy lab to see this stuff in action. All you need is water and the right kind of salt. For instance, if you dissolve sodium hydroxide in water, boom, the water gets hot. But if you dissolve ammonium nitrate, and yep, that's the exact same chemical inside an instant cold pack, the water gets shockingly cold.
Okay, so talking about it is one thing, but let's actually see what this looks like when we put it to the test. So check this out. In the beaker on the left, we add sodium hydroxide to water, and look at that thermometer. It shoots up 10 degrees Celsius. That's a classic exothermic reaction, releasing heat. Now look to the right. We add the ammonium nitrate, and the temperature plummets by 6 degrees. That is the endothermic reaction at work, literally pulling the heat right out of the water.
So that probably gets you thinking, right? If a little bit of this stuff makes the water cold, what happens if we add more? Can we actually control just how cold or how hot it gets?
Well, the data gives us a big, loud yes. Take a look at this experiment with lithium chloride, which gets hot. With just 1 gram, the temperature jumps 4.5 degrees. But if you dump in 4 grams, whoa, it jumps a full 18 degrees. It's not random at all. It's a completely predictable relationship.
And if you plot that data on a graph, the connection is undeniable. It's just a perfect straight line heading upwards. The more stuff you add, the bigger the temperature swing. And this isn't just some neat science fair trick. This is exactly how engineers figure out how much chemical to put in a hand warmer or a cold pack to get it to just the right temperature.
Okay, so here's where it gets really interesting. What if I told you that some of these reactions aren't a one-way street? You can actually run them forwards and then backwards. And when you do, the heat effect completely flips. Let's take a look at a substance called copper sulfate. When it has water molecules locked into its structure, which scientists call its hydrated form, it has this really beautiful, vibrant blue color.
Now watch what happens when we heat up those blue crystals. The heat from the flame is basically forcing those water molecules to escape, and because it takes energy to do that, this process is sucking up heat from the flame. It's an endothermic reaction, and what you're left with is just a plain white powder.
But here's the magic trick. You add a few drops of water back to that white powder and bam! It instantly reverses, turning right back into that vibrant blue. And as it does that, it releases all that stored energy as heat. This reverse reaction is exothermic. This exact cycle, absorbing heat in one direction, then releasing it in the other, is the core principle behind your refrigerator.
And that brings us to the main event. We've seen how these reactions can absorb and release heat in a beaker. Now, let's apply that same logic to the big metal box in your kitchen. So here's the whole system. Your refrigerator is basically running the same kind of reversible cycle as our copper sulfate experiment. But instead of a chemical reaction, it's using a reversible physical change, the evaporation and condensation of a special fluid called a refrigerant, all happening inside a closed loop of pipes.
This whole amazing process can be broken down into these 4 key steps. And it's all about that refrigerant constantly changing from a liquid to a gas and back again. So let's start inside the cold part of your fridge. A high-pressure liquid refrigerant is forced through a tiny little nozzle. As soon as it comes out the other side, the pressure drops and it instantly expands and flashes into a gas. In other words, it evaporates. And what have we learned about evaporation? It takes energy. It's a powerful endothermic process.
That evaporating refrigerant starts soaking up a huge amount of heat energy from everything around it, from your milk, your vegetables, you name it. And that's what makes the inside of your fridge get cold.
Now that the cold gas has absorbed all that heat, it gets sucked into a compressor. That's the part that makes that humming sound. The compressor, well, it compresses. It squeezes that gas, which causes its pressure and temperature to shoot way up. It's now a very hot, high-pressure gas.
This super hot gas is then pumped through all those coils that are usually on the back of your refrigerator. As it travels through those pipes, it gets cooled down by the regular air in your kitchen.
And as that hot gas cools, it condenses back into a liquid. And what happens when a gas turns into a liquid? You guessed it, it's an exothermic process. It releases all the heat it originally stole from inside your fridge and dumps it out into your kitchen. That's exactly why the back of your fridge always feels warm.
So this is the most important thing to remember. Your fridge doesn't create cold. There's no such thing. It's really just a heat mover. It uses the endothermic process of evaporation to grab heat from the inside and the exothermic process of condensation to dump that very same heat on the outside. And this whole thing just keeps going. That liquid refrigerant goes right back to the start of the loop, ready to evaporate and absorb more heat all over again. It's a brilliant, continuous cycle of science working around the clock in your home.
So from a simple cold pack all the way to your kitchen refrigerator, the principle is exactly the same. It's all about absorbing and releasing heat. So the question is, now that you know what to look for, where else do you see this fundamental dance of energy playing out in the world around you?